Hello, I am going to talk about deflection by energy method. Here we are discussing unit load method or virtual work method for a perfect, stable and statically determinate pin jointed plane truss. So let me begin. Now we can write WE dash equal to UI dash, that is assumed external virtual force P dash into the unknown real external displacement delta is equal to summation of virtual, or you can say imaginary, internal forces N dash into known internal displacements D. Now let me take one truss element of length L which is subjected to force P as shown here. Now we know from strength of materials that due to application of this tensile load P, this element will try to elongate, and therefore the final length is L plus D, where D is the change in length or displacement. Now we know that linear strain epsilon is given as D upon L, that is change in length by original length, and therefore D becomes epsilon into L, that is strain into original length. But again we know that strain is nothing but stress sigma by Young's modulus E, therefore we can write D is equal to sigma by E into L. Again we know that stress sigma is load divided by cross section area, that means for this truss element which is subjected to load P, the stress at any cross section is load by area, that is a axial stress, and therefore when I substitute sigma as well as epsilon, when I substitute everything, then D becomes PL by AE, where P is the load, L is the length of the member, A is cross section area and E is Young's modulus of the material. AE is also called as axial stiffness. Now let me go further. Therefore again we can write W dash equal to UI dash. So as I already mentioned, it will be P dash into delta is equal to summation of N dash into D. Therefore I can write delta is equal to summation of N dash by P dash into D. Let me call it as equation 1. Now N dash by P dash is nothing but virtual internal forces, that is N dash, divided by P dash means assumed external virtual force. So this total N dash by P dash I can call it as K. Now this K is nothing but the internal axial force which every truss member undergoes due to a unit load applied at a joint where deflection is needed. That means we apply 1 Newton or 1 kilonewton as the case may be to the joint where we want the deflection, and then we measure K forces, that is virtual or imaginary forces in all the members, and therefore when I substitute N dash by P dash equal to K, then equation 1 becomes delta equal to summation of PKL by AE. So this is the equation for a pin jointed plane determinate truss to find the deflection at any joint by using unit load method or virtual work method. Let me take a very basic and simple problem to understand this concept practically. So the problem is, for this given truss, determine vertical deflection of joint B, cross section area of each member is 1000 mm square and Young's modulus is 2 into 10 raised to 5 Newton per mm square. So first what we have to do is calculate the reactions. Now it is obvious that loading is symmetrical and therefore vertical reaction at A and vertical reaction at C, they are half of 20 kilonewton, that is 10 kilonewton and 10 kilonewton above, upwards. Again let us go for P analysis, that means due to external load by method of joints. Again we know that in method of joints, here we can either start with joint A or joint C, because here it is a concurrent force system at every joint and there are only two equations of equilibrium which are available at every joint, that is summation of Fx equals 0 and summation of Fy equals 0, and therefore we have to select a joint having 2 or less than 2 unknowns. Therefore we cannot start with D or B, we have to start with A or C. But again if we look at joint B, coincidentally there are no diagonal members and therefore there is no load at B, there is no vertical load, and therefore we can say that the force carried by member BD is 0. So PBD is equal to 0. Now we can consider free body diagram of joint A as I have drawn here. So I am assuming force in AD and force in AB as tensile, The angle is 53.13 because tan theta is 4 divided by 3, and here the reaction is 10 kilonewton. Again, when I take summation of Fy equal to 0, it gives PAD sine 53.13 plus 10 equal to 0. So when I solve, PAD becomes minus 12.5 kilonewton. Here our sign convention is we assume initially tensile and we take it as positive, and if answer comes out to be negative, it's obvious that the actual force is compressive. So the force in PAD is compressive. Now again it is obvious that whatever PAD I am getting, same I will get in PCD, and therefore PCD is also 12.5 kilonewton compressive. I don't have to really solve it. Just I have to write that PAD equal to PCD. That is what I have written here. Now again summation of Fx equal to 0 gives, for the same joint I am applying, minus 12.5 cos 53.13 because PAD I had assumed tensile, but it is now compressive. So arrow will be reversed. So minus 12.5 cos 53.13 plus PAB is equal to 0. When again I solve, PAB comes out to be positive 7.5 kilonewton. That means it is tensile. So again it is obvious that whatever force PAB is experiencing, same PBC or PCB is also there, and therefore PAB is equal to PCB. Now going next. Now I have to go for K analysis. That means imaginary analysis due to virtual load of 1 kilonewton at B, again by method of joints. So now I have removed the original load of 20 kilonewton and only applied 1 kilonewton at B. Again it is obvious that due to symmetry, the virtual reactions and at A and C are 0.5 kilonewton each. Now again at joint B, there are no diagonal members and only 1 kilonewton load vertically downwards. Therefore, for equilibrium of B in the vertical direction, KBD, that is virtual force in BD, that should be 1 kilonewton tensile. I don't really need to analyze it there. Simply I can write KBD is equal to 1 kilonewton, so that this 1 minus 1, it becomes 0. Again when I consider equilibrium of joint A, I can say that this is KAD and KAB, and this is 0.5 kilonewton. Again summation of Fy equal to 0 gives KAD sine 53.13 plus 0.5. When I solve, it becomes minus 0.62 kilonewton. That means it is 0.62 kilonewton compressive. And again it is obvious that whatever KAD I am getting, same I will get KCD. Similarly, summation of Fx equal to 0 gives minus 0.62 cos 53.13 plus KAB equal to 0. This is minus 0.62 because KAD I assumed tensile, but answer came out to be negative, so it is compression. It is compression actually, and therefore I have to substitute here minus 0.62 cos 53.13 plus KAB is equal to 0. When I do solve, KAB is 0.37 kilonewton tensile, so which is same as KCB. So when I again make this table, part P, K, L and PKL, so I write all the forces here, that is AD, CD, AB, CB and BD. I write minus for compression and plus for tension. So I have written all lengths of all the members, and when I took PKL of each, that is shown in last column, and when I took summation of PKL of all these values, then it is 94.15. And therefore delta BV as per unit load method or virtual work method is summation of PKL divided by AE, that is 94.15 divided by area is 1 into 10 raised to minus 3 meter square, and Young's modulus is 2 into 10 raised to 8 kilonewton per meter square. When I solve, I get 0.00047 meter, that is 0.47 mm in the downward direction. So thank you very much.